to find in your refrigerator. You may know it as an egg, and that's what today is all about. Eggs. What goes on? Why are eggs so popular? And where do they come from? So, and also what can we do with them? So we're gonna go into a little bit of what is in the egg. We're gonna look at a few different types of eggs, and then we're gonna actually make a few different dishes with eggs. So let's get started here. Some of the things are gonna need a few minutes to set up, so we're just gonna get those going right away, and then we'll talk about them in a little bit. So, what is in an egg? Eggs, everyone knows they're packed full of proteins, right? If you're trying to build muscle, they say eat a lot of eggs. They're packed full of protein. Well, can you see the protein in there? How much protein do you see? We actually have a few different parts of the egg. We have obviously the yolk. You can see the yolk is the big bright yellow thing. We got the chalaza. The chalaza is the white strands coming off the yolk, which is, this doesn't mean your egg's bad. This is actually important to stabilize the yolk while the embryo is developing. And then we got the albumin. The albumin, also known as the egg whites. So that's the fancy name for egg whites. We can call them egg whites from here on out, just to make it easier on everyone. Some people may think that this whole thing turns into a chicken, right? Well, actually, the only spot that the chicken actually, the spot where it starts, is the germ disc, the germination disc, which is a little tiny circle or dot. It's really hard to see on commercially farmed eggs because they don't ever fertilize their eggs, so they don't need that specific type of chicken. But if you go to your farm fresh eggs, you'll see like a little spot, maybe sometimes it's brown, sometimes it's just a little slightly different color, and that's called the germination disc, and that's where the actual information of the embryo is going to start developing. That's where the fertilization is going to actually take place. And what's amazing about eggs is that everything that is needed to sustain life is held within this outer shell. So we know that they're packed full of proteins. They have everything that we need for life inside this shell. Many of you heard of hard-boiled eggs. So you can see that this is just a liquid. How does it become a hard-boiled egg? How does it become hard? So let's take a further look at it. I'm going to put my egg into the boiling water. Oh, cracked it. I'm going to put 2 in just because I cracked that one.
It doesn't seem to be leaking though, which is not bad.
Yeah. Some things that you're not able to see on in our plate is that there's actually, so obviously there's a shell. There's an outer shell. Outer shells are actually porous. They have tiny little holes in this outer shell. This outer shell is made up of calcium carbonate. Calcium carbonate is basically like what shells are made out of, like seashells are made out of it, limestone's made out of it. It's even an additive in concretes. So those are all pretty hard substances. So it makes for a great shell. So an interesting thing about shells is it needs to be strong enough to protect itself from a hen sitting on it, other outside environment pushing in on it, but also needs to be permeable to allow carbon dioxide out and oxygen in, and some liquid. So it's really interesting structure. It also needs to be fragile enough to allow the hatching chick to be able to break out of it, which is quite a task for a brand new chick that has never taken a step in its life before. So there's an interesting balance in between stability and weakness, because they both need to be in that right zone for a chick to successfully hatch. All right, so we all cook eggs. That's basically what we're doing here. We're cooking eggs in water, and it's going to turn from a liquid to a solid. How does that happen? Well, eggs are made of tons and tons and tons of proteins. So, proteins, if you remember back from your biology class, are folded in the endoplasmic reticulum. So, they're made in the ribosomes and folded in the endoplasmic reticulum. So, they need to be folded to perform specific duties. So like enzymes are proteins. They need to have a specific shape in order to pair with specific molecules to help break them down. So all these eggs are packed full of protein. And this is kind of what it looks like, floating around in the albumin, or the white egg whites, because that's where the most density packed area of the egg is going to be the egg white. So they're all floating around all of a sudden, and the interesting thing about proteins is that they're kind of fragile. As soon as they start to be heated up, if they get too hot, they start to denature, and that means that they actually unfold. So these are my proteins here, and pretend like I just put this egg on the pan. These proteins are going to start to denature, and all of a sudden they start to flatten out, and instead of just sticking to themselves, they break those hydrogen bonds that keep them folded, and they elongate. All of a sudden you have these long proteins that are easily matted together. So all of a sudden, instead of you having free-floating proteins that didn't really want to stick to a bunch of things, you have elongated proteins, which actually take up a lot more space than when they're folded, because they're folded very tightly and very specifically so when they expand and denature, there's actually a lot of material that their surface area actually increases. So this is kind of what it looks like when you cook or denature eggs, and then that's where we get the hardness from. An interesting thing about proteins is you don't just need heat to denature proteins. Different pHs can denature proteins. Different acidities can denature proteins. So alcohol can denature proteins. So to prove that, we're going to cook an egg without using any heat. How am I going to do that? Well, first, I'm going to put my egg right in this dish, and I'm going to add 91% isopropyl alcohol. 91% isopropyl alcohol.
And it's already started doing something.
Yeah, you can see that the egg white is actually changing color. So we'll let that sit. It's got to diffuse into the yolk and into the egg white. So we'll just put that off to the side, and we can check in on it as we go. So it's already denaturing the proteins. So those are at work right now. All right. So eggs. When you think of eggs, what are you thinking of? Probably the exact same thing that's right here in front of me. Plain white egg that you get from a chicken. Well, we as humans actually consume a variety of eggs, and they don't even have to come from chickens. Very popular eggs to eat are like quail eggs, duck eggs, and in fact, we don't even just eat eggs from birds. We actually eat fish eggs in the form of caviar. So like salmon eggs, sturgeon eggs, trout eggs. Those are all forms of eggs that we consume. Again, all of eggs are nutrient packed, have everything that can sustain life. So an embryo, everything that embryo is going to need is already packaged in that egg. So that's why they're so good for when we eat them. All right, so ostrich eggs. Here's an example of an ostrich egg. You can definitely see that there's definitely a difference in sizes between an ostrich egg and a regular egg.
Also shape.
What?
Also shape.
Different shape? Yeah, this is a little more oval. This is a little more teardrop kind of. Even
Array egg.
yeah, we have different types of ray eggs, some kind of emu eggs. So obviously you see that there are different colors on them.
We have array egg.
Here is a quail egg. So you can compare this to an ostrich egg. Quite a different species, different birds, different needs. The ostrich egg is much thicker than this quail egg because, you know, an ostrich is gonna weigh more than a simple quail. Even just in between chickens have different shapes and sizes of eggs. Here's a variety of chicken eggs. You can see that you can have different shapes and sizes. You can have almost like a green-blue type of egg. You can have brown eggs. You can have spotted chicken eggs. You can have white eggs, and they can be different sized eggs. So even though that they're different on the outside, that doesn't change the fact that they have everything that they need to sustain life inside that shell.
And bird eggs are relatively uniform in internal composition, basically.
Yeah. So, where do eggs come from? They actually are dropped out of the ovarium of a hen chicken. And it takes about 1 day from when that egg is released from the hen to pass through all of the different channels and to form a actual egg. So a mature hen can lay an egg a day if they're in the proper conditions, proper sunlight, nutrition, and temperature. So those are all. That's really kind of blew my mind that they can just pump out something so large compared to their body size, because I don't know, doesn't seem very comfortable.
Also, like so much nutrients go to that. Because they have to be eating a really healthy diet.
Yeah, they have to be heavy on the nutrients. A lot of farmers actually have to supplement a lot of different types of carbon acetates into their chickens' diets just to compensate for all the shells that it's going into. So back to the shell. It's really interesting things about the shell. So we mentioned that the basis of the shell is calcium carbonate, which is also a few different things like limestone, basis for some concrete additives, and chalk, tums. Those are all basis of calcium carbonate. And one really cool thing that you can do with an egg is actually dissolve the calcium carbonate of the egg by just adding it into a vinegar dish and letting it sit overnight. And you'll actually dissolve that outer layer and be only left with the inner membrane of the egg, which is pretty interesting and fun experiment to try at home. I didn't have enough time to do that today, so I'm just going to skip over it. Some things, other pieces and parts of the egg, there's actually a air cell in the egg, in every cell. In every egg, and this actually gets larger as the egg sits. So the old saying is, how do you know if an egg is actually good? Is if you put it in water and it sinks, then it's still fresh. If it is not and it floats, then it is supposedly older. Well, that's because of that air cell. That air cell gets bigger as the egg ages. This happens in fertilized fertilized eggs and non-fertilized eggs. So you can try it at home with old eggs that you have in the back of your fridge. So where does that oxygen come from? Again, it's passing through this semi-permeable membrane cell or shell. So it's allowing carbon dioxide and liquid to evaporate, pass out, and oxygen and it's taking in oxygen. So, all right. Eggs have a ton of protein. Proteins are made up of long amino acid chains. That's why I use those long pipe cleaners to represent the amino acid chains, the eggs, proteins. So, one really good thing that is used in the culinary world is it's used to do immersion dishes. So like mayo is an immersion. It's a mixture of water and oil. So everyone knows that water and oil don't mix, right? But I'm gonna add some water and oil to this. And I'm going to blend it up. So this is basic of your hollandaise sauce on your eggs Benedict, the base of mayo. That's all the basis of that is an immersion. They use egg whites. I'm gonna take out the yolk. Save that for later. So, all right, got egg all over my hand. So, let's see how it goes. So, egg water, egg white. Let's give it a shot. Let's blend it up. All right. We've blended up our immersion. Let's take a look at it. Pour it into it. Something we can look at. So typically you would see a separation between water and the oil, right? But because we have that egg, you actually you don't get that separation that you would in with water and oil. So how does that work? Well, there's lots of spots to be able to bind to proteins since they're so long, and so it actually is able to bond with the oil molecules and bond to the H2O molecules. So it prevents them from being able to separate themselves again. That's how you get the delicious condiment put on your sandwich. You bet you didn't even think about that egg science when you were eating your sandwich the other day. All right, I'm gonna put those off to the side. All right. What else? So, what's our time here on this video?
We are on at 19.
Okay, so we must be done with our hard-boiled egg. Whew. A lot of times people like to put those in an ice bath to help shock them, but I don't have any ice, so it is very hot. All right, so again, we started the beginning of the show with talking about how we denature proteins with heat, different types of acid, and alcohol. So we put this in a bath of water. It was liquid, in the form of liquid. Now, when we took it out 10 minutes later, we got a solid white yolk. Some people like over easy on the yolk. Well, looks like this yolk is already done. You can see that we are able to cook all the way through and to the yolk. So that's what's actually happening when it transforms from a liquid to a solid, which is pretty interesting. So you can see there's different layers in the egg in the crosscut. The egg white is packed full of protein. That's where you're going to find most of the protein and liquids. On the inside is the yolk, and that's where you're going to find more of the vitamins and fats and still some proteins, but more vitamins are going to be located in that yolk, which makes sense because that's going to be the closest area to the embryonic embryo. So, science in the hard-boiled egg that you eat. Take one more bite, and we'll move on. Okay. So, we're denaturing eggs. Denaturing proteins in the egg. We added the alcohol to the egg, and take this. Save that for later. And we're going to try to fish this out. Alright. Try to fish this out of the alcohol bath. Alright, so you can see that it looks similar to what an egg would look like if you cooked it on a pan. We didn't have a great ton of time, but if you left it in there longer, you'd get a better look. Here's one that I started actually earlier today, and you can see, maybe you can't see, that it is actually almost just as like you would breaking. Oh, look at that. 2 eggs, sunny side up, cooked with alcohol. That's pretty impressive. Don't eat it. If you try it at home, don't eat it. It's way too much alcohol for your body. It's not meant to be eaten. Awesome. So, denaturing proteins, cooking eggs with no heat. Man, how else could today get any better? Well, today you're going to learn how to make the perfect scrambled eggs. Just because we've been doing so much learning in the past 20 minutes, now we're going to get to the good stuff. Delicious and good to know, because who doesn't love breakfast? I know some people that don't eat breakfast, and I'm just like, how do you get through the day? You must be crazy. So, what you need for a perfect breakfast, perfect scrambled eggs, is going to be, obviously, eggs. I prefer farm eggs, but today I'm using just regular old eggs. You need a little bit of fat. You could use it, you could be in the form of oil or butter. I like to use butter because butter's amazing. I always like to add cheese when I'm done. And the secret touch, sour cream. So, I'm getting my pot up to temp. Alright, so I'm gonna add a little bit of butter. Add a little bit of butter, get that going. You're going to want to add your eggs directly to the pan. So a lot of people like to whisk them before. I like to just add them right to the pan. Saves dishes, and it's okay that things cook at different speeds. All right, that should be enough eggs. Boom. All right, I like to wash my hands after I crack them. I guess I can just switch them. There you go. Save me some time. All right, so right away you're gonna want to start folding them, mixing them up in the pan. It's important to keep mixing them to aerate the egg. You don't want to stop and allow them to get thicker on one side than the other. So you're going to want to be constantly stirring them, kind of like a souffle. And always kind of be stirring them up, aerating it. Typically people like eggs that are light and fluffy, which I also do. So you want to keep it going, make sure it's not burning on the bottom, moving it around, folding it up. And if you like to add anything to your eggs, it'd be a good time to start sauteing them in a separate pan. Put them in butter, saute them up. Can't go wrong. Alright. An important thing about eggs is to make sure that you don't overcook them. But all of a sudden, once you overcook them, all the moisture's gone, and you're kind of just eating rubber. So, as you become closer to the finish, you're gonna wanna take it off. Take it off the pot, put it on, get your sour cream ready. Adding the sour cream is basically the same as that immersion. It helps separate those proteins, keeps them nice and fluffy, and also adds a little bit of texture, so creamy and a little bit of tang to your eggs. So I'm going back on the hot plate for a second to finish them off. Again, they're gonna continue to cook even when they're off the hot plate because your pan is still hot. All right. So here we go. Our nice light, fluffy eggs. Oh, we're in a hot pot. Go ahead. Add a little bit of cheese, light cheese on them, and you're good to go. Well, I got some eggs to eat. I showed you, today was all about denaturing the proteins in the eggs. We saw different ways that you can denature proteins. We saw it with alcohol. We saw it with boiling it, and then finally frying it on a pan. So, hope you enjoyed your next breakfast. And if you want to learn more about eggs, come on down to the Headwater Science Center any day, 7 days a week. When? What times? Well, Monday through Saturday, you can come in 9:30 to 5 p.m. And then swing by after lunch on Sunday, 1 o'clock.